In this video, we'll discuss the period of a pendulum. So far, period T, capital T, right, has been the time to form a wave. Remember how we did this? We start at 0, it takes 1 second to go to the crest, 1 more second back to the center line, 1 more second to go down to the trough, and finally after 4 seconds we form a full wave, and that's our period, capital T, 4 seconds for this transverse wave. We can broaden that to describe anything that displays harmonic motion, which is back and forth motion. Anything back and forth, we can discuss as period. Now, the transverse wave, you may not have thought of it before, but that is going back and forth, isn't it? Isn't it going back and forth across that center line? Sure, back and forth. So we can talk about its period. How about the pendulum? Is he going back and forth? Sure, that ball will start here, go that way, and come back and forth, back and forth, back and forth. So this thing does display harmonic motion back and forth, left to right. And so because it's doing that, back and forth harmonic, we can discuss its period. Now back here in the transverse wave, we saw it before. It took 4 seconds to go back and forth once. That was its period. How about here? Let's say we start at 0 here. We swing over it at the top over here with 1 second. It takes a whole second to come back. So after one back and forth is 2 seconds. That's our period. Again, it's back and forth, everyone. It's not one way. Your period here is not 1 second. It's back and forth, 2 seconds. You see how we can use this here? Not just with waves, because this pendulum is moving with harmonic motion back and forth. Let's do a quick word problem here to calculate the period of the pendulum. And don't think too hard. Really, all we need is you ask yourself, how many seconds per back and forth trip? So a pendulum swings back and forth 15 times in 10 seconds. What is the period? I simply want the number of seconds for each back and forth trip. And so don't think too hard. We have 10 seconds, and in that 10 seconds we go back and forth 15 times, which is going to be 0.6 seconds per trip. Our period is 0.67 seconds. It's just the time to go back and forth. In this case, 10 seconds divided by 15. There it is. Your video code is back forth. Back forth. Let's finish with 3 other examples, because you can calculate period for anything that displays harmonic motion back and forth. Just 3 other examples. What if this ball was on a round kind of a track here thing? Couldn't it roll down here and roll back, go back and forth? Sure. Let's say it took 0.4 seconds to get halfway around and 0.8 seconds to come back. The time to go back and forth is 8 seconds. That's the period. This thing here is called a metronome. When I was taking piano lessons as a kid, we put one of these on the piano to tell us how fast to go, and so this thing goes back and forth here. Let's say it starts at 0, goes over here in 0.15 seconds, and comes back here in 0.3 seconds. One back and forth trip. Our period T is 0.3 seconds. This guy here is throwing this ball up and down repeatedly, back and forth, up and down. We can talk about period there, can't we? She starts at 0, when the ball to the top is at 0.8, it comes back to the bottom where it started. One back and forth trip is 1.6 seconds, and that's our period. Okay? That's it. Anything that moves in the harmonic motion, if you calculate the time to make one back and forth trip, you've got its period, capital T. Bye.